All right, guys. So thank you for coming to the WebEx session. So our goal for today is that we can identify the reactions and products of combustion reactions. Okay. Um, so moving on here. All right. So our APK for today is what would you need to keep a fire burning? Okay. So I'll give you guys about 30 seconds. So write your answer in the chat there. Okay. So what do we need to keep a fire burning? Sorry, guys, one moment. All right. I think. All right. So we got here heat, oxygen, fuel. Okay. Okay. I think that's pretty good there. So yeah, we need heat, oxygen, and fuel. Now, I don't know if you guys have heard of the what do you call it? The fire triangle. Oh, I need to learn how to spell there. So fire. So we need fuel. All right. We need oxygen there, and then you would also need um, an ignition or spark, right? So you would need all three to keep a fire going. Okay, so what that means is that if you take one of these three out, okay, you would put out a fire, and this is how firefighters they they put out a fire, right? So normally what you do is you would spray a fire with water, and what the water does is that because it covers up the fuel doesn't react with the oxygen. Okay, the oxygen doesn't get to the fuel, and so therefore you put out a fire. Okay, also the water kind of lower the temperature as well, so you don't have that ignition for the fire to keep going. Um, with the fire extinguisher, right? It's also trying to get rid of the oxygen there. So that's the easiest thing to do. It's just to get rid of the oxygen, right? The other thing that you can do is try to have a control fire. So as long as the fire uses up the fuel, it will put itself out, right? So that is with a controlled fire. Right, now moving on here. This is what we're going to be learning. All right, so combustion. Now we have learned about combustion before when we talk about the types of reactions. This is going to be a more in-depth look into combustion reaction, okay? So first of all, combustion is an exothermic reaction. Think about the word exothermic, okay? So thermic, that means temperature, okay? And exo here, think about the word exoskeleton. So exoskeleton is when you have the skeleton on the outside, okay? Now exothermics means that it gives off heat. It gives heat to the outside, okay? So as it says there, an exothermic reaction is when you have a large amount of energy being released as heat. Okay, so that's what exothermic reaction is. Now we've learned that combustion reaction is when you have a fuel reacting with an oxygen, and so you're going to get carbon dioxide and water. Okay, so these are the notes I would like you to write down for me later. I'm just going to go through the notes very quickly here for everyone. Now one type of fuel is hydrocarbons. So they are compounds that are made up of hydrogen and carbon, right? Hydrocarbon. Now examples of hydrocarbons are coal, petrol, natural gas, and diesel. The important one that I would like you to write down for this slide, I would say, is the first one here. Okay, that one particularly. And if we go back to this one, so these two are important, and also this as well. Okay, so this slide, everything you need to write there, or try to summarize um, the notes on here. If you know what an exothermic reaction is, you don't have to write the second part, but if you don't know, or if you would like to have the notes anyway, you absolutely can write everything. Now here we got an image of the simplest form of hydrocarbon. Okay, so that's methane. You may have heard of methane before. They are usually sold in like the small cans. Okay, so methane, or also the gas that we use in at school for our Bunsen burners. That's also methane as well. Okay, so when you can see here that methane, when it reacts with oxygen, it will create carbon dioxide and water. So every fuel, when it reacts with oxygen, when it burns in oxygen, will create carbon dioxide and water. Okay. Um, so I would like you guys to at least know this word equation. Now, if you would like to extend yourself, then you can have a look at this one as well. Okay, so CH4, that's the chemical formula for methane, plus oxygen, so O2, gives you CO2 and H2O. Now, the reason why we've got the 2 here in front of the O2 and the 2 here in front of the H2O is because um, everything needs to balance in a chemical equation. Okay, so what do I mean by that? So here I've got one carbon on the left hand side. I've also got one carbon on the right hand side. I've got 4 hydrogen on the left hand side, and here I've got 2 groups of 2 hydrogen, right? So each H2O has got 2 hydrogen. If I've got 2 of them, that means I've got 2 groups of 2 hydrogen. So in total, that's 4 hydrogen. So 4 and 4, that's balanced. And then I've got 2 groups of 2 oxygens. That's 4 oxygen on the left-hand side. And then I've got 2 oxygen in the carbon dioxide, as well as 2 oxygen for the water. So that's 4 as well. Okay. So so this second equation is what we call a balanced chemical equation. So again, that's for people who would like a bit of extension. We will go through balancing chemical equations later if we got time. But for now, I just need you to know, at least for me, the word equation there. You need to know for me that, hey, if I burn a fuel, I'm going to get carbon dioxide and water. Okay, and I think you guys are pretty okay with that. The other thing I would like you to know and to write down is what happens when you have not enough oxygen. Okay, so when you have less oxygen, what you have is you have an incomplete combustion. Okay, so the hydrocarbon plus limited amount of oxygen would give you carbon monoxide and water. Okay, For those who are interested, carbon monoxide, the chemical formula for it is CO instead of CO2. Okay, CO2, carbon dioxide, has 2 oxygen. Here, because we have less oxygen, you can only have one oxygen with a carbon. Okay, so carbon monoxide. Now you may also have heard about carbon monoxide poisoning. So this is particularly in like burning buildings. Okay, if you are if you if people are trapped in a burning building, there will be a buildup of carbon monoxide, and what can happen is people would pass out from breathing this gas in, and it is a poisonous gas. Okay, um, and because it's also odorless, people don't know that it's there, but but it can pass people out. Um, and then you also have hydrocarbon plus limited oxygen will give you carbon as well. So carbon here is in the form of like smoke. Okay, when you see like very black smoke, that's because of the carbon. That's because of the soot. Okay, and also, you know, once everything's done, like once everything burns, then you're left with charcoal as well. Okay, and that's also a form of carbon. Okay, so these are what happens um, when you have not enough oxygen reacting. Okay, so with all of that, and I should say, get these down for me. All right, including actually, you may not to these for me. You don't need to write the last one here. Okay, and with that, I would like you guys to do the task on Education Perfect. Now, when you go onto Education Perfect, and Riley, I will um, fix that thing on Education Perfect for you. Okay, when you go on to Education Perfect, this is what you should see. Let me just get things ready here. How are we doing on time? Okay, we're still good. All right, so all right, I can see here that one person has started already. That's very good. Um, okay. All right, maybe while I'm waiting for this to load, I will also fix up this thing on Education Perfect. Okay. So this is the one that you need to do. Okay. This is the one that you would have here. So 10 Science Term 3, Week 5. So when you get in here, you see that there's a few lessons. Now what we're going to do is we're going to work on combustion reactions today. The rate of reactions, these three here, will be for Wednesday. Okay, I'll go through that on Wednesday. Now, if you finish with combustion reactions and you want to move on ahead, feel free to. Okay, you don't need to wait for me to start with that. So this is what you're gonna have, okay? Read through the information slides again, pretty much what we've gone through, what you need to know, and then do the questions for me, okay? So that is what you need to do for today to combustion reactions. All right. So with that, um, thank you for coming to the WebEx. If you feel confident, you can go ahead and do your work. If you need any help, you can stay and I will help you, or you can email me. All right. Thanks, guys.